Welcome to the lecture on design of machine members 1. In today's class, we'll be starting the unit number 2, that is design for fatigue strength. In this unit, we'll discuss variable stresses, fatigue failure, fatigue strength, endurance limit, design for variable stresses by using the three different methods: Gerber's method, Goodman's method, and Soderberg's method. Stress concentration, factors that are affecting the stress concentration, how to reduce the stress concentration, and cumulative damage in fatigue. So these are the things we will discuss in the unit number 2. Here, in the introduction to the variable stresses, we know that the components of a machine are subjected to forces which are not static. They're going to vary either in the magnitude or in the direction with respect to the time. It is observed that 80% of the failures of mechanical components due to the fatigue failure. First, let us try to understand what is fatigue. Fatigue is the condition of an object which, when subjected to the fluctuating or alternating or variable stresses with respect to time. If the stresses are variable in nature and they are applied over a period of time, then the member is going to fail at a value which is much lesser than its failure value in simple tension test. So that condition is known as fatigue, and that is the failure is known as fatigue failure. So for the purpose of the design analysis, for the purpose of the design analysis, simple models for stress-strain relationships are used. There are three different models are taken. First one is fluctuating or alternating stresses. So here the stress varies in the sinusoidal manner with respect to time between the limits of maximum and minimum stress. And there is maximum value and there is minimum value. None of them is zero. And then the second category is repeated stresses. So that means there will be some maximum value and the minimum is zero. The minimum is zero. That means zero to certain value, positive maximum value. It goes and again comes back to zero, and that is known as repeated stresses. And third one is reversed stresses. That means there will be a positive value of certain magnitude, and after that there will be same magnitude of negative value, and this will continue. So this may be on the rotating members like shafts. The shaft is subjected to a load in the downward direction from a contact point, and shaft rotates. Then the contact point changes with each degree of rotation. After 180 degrees of rotation, the member, which is the layer of the member which is at the top, will go to the bottom, and then it is subjected to tension. When it is at the top, it is subjected to compression. So this compression and tension are going to change with respect to the time. So this category is known as reversed stresses. Fatigue failure. You can see the graphs for all the three types: fluctuating stresses, and then repeated stresses, and then reversed stresses. From these, we are going to find out the mean and variable. The mean value of stress is, as you know, the average of maximum and minimum, and the amplitude stress or variability of the stress is equal to difference of the two stresses divided by 2. Fatigue failure is defined as time delayed fracture under cyclic loading. The examples are transmission shafts, connecting rods, gears, vehicle suspension springs, ball bearings, etc. So let us try to distinguish the failure due to static and the fatigue loading conditions. In a simple tension test, the load is gradually applied and there is sufficient time for the elongation of the fibers and for the plastic deformation before the fracture. Whereas in the fatigue loading condition, the failure begins with a crack at some point in the material. The crack is more likely to occur in the following regions. Number one, the regions of discontinuity. It may be oil hole, keyway, screw thread, etc. And second region of irregularity such as scratches on the surface or stamping marks, etc. And third one is internal defects like blowholes, etc. So these are the points where the crack may be initiated, and that crack spreads due to the fluctuating nature of the stresses until the cross section of the component is reduced the remaining portion and it is subjected to sudden fracture. So as the first sentence says, it is the time delayed fracture under cyclical loading. So there is a crack initiation and then crack propagation and finally the fracture or separation takes place. Endurance limit. This is very important point in the fatigue failure conditions. The fatigue or endurance limit of a material is defined as the maximum amplitude of completely reversed stress a standard specimen can sustain for a number of cycles without failure. So it is the endurance or the fatigue limit of a material is the number of cycles before the failure occurs. This endurance limit is very important for the design of machine elements or components which are subjected to the variable stresses. The one which is having more than 10 power 6 cycles of life can be treated as infinite life, and less than 10 power 6 is finite life. The fatigue stress, uh, it is tested for the endurance limit. In the laboratory beam balancing machine, the specimen is prepared as shown in the figure 5.17. So at the middle, uh, the diameter is 7.5 and total length of the specimen is 85 and the curvature is 250 radius and it is subjected to the bending. As this is subjected to bending, the upper portion is subjected to tension, whereas the lower portion is subjected to compression. That means the bending is taking place in this manner. There is a hogging condition. In the hogging condition, the upper layers are subjected to tension and bottom layers subjected to compression. But this specimen is made to rotate. When it is made to rotate, what is going to happen? The upper layer, after 180 degrees of rotation, will be coming to the bottom, and the bottom layer will be reaching to the top. So now the layer before 180 degrees rotation, it was in tension, now it is in compression. So the tension and compression, these are going to change with every 180 degrees of rotation. So it is called cyclically varying stresses. The member is subjected to cyclically varying stresses. The maximum value of bending stress is calculated by the bending equation. Bending stress is equal to uh, m by I into y, where m is the bending moment and y is the distance of the fiber from the centroidal or neutral axis. I is the cross-sectional moment of inertia of area. So here you can see the rotating beam fatigue testing machine. Here is the specimen placed, and it is being rotated and also subjected to weights, and weights are causing bending moment, that is a hogging moment. Upper layer subjected to tension and bottom subjected to compression, and they are being rotated by the electric motor, and number of revolutions made by this specimen is counted here in the revolution counter. The weights you can attach, you can reduce the weight on the specimen, then thereby you can increase or decrease the bending moment. Here a plot for the number of cycles versus the stress induced in the member. This is called famous SN curve. S stands for stress and N stands for number of cycles. And from the rotating beam fatigue testing machine, this SN curve is plotted for different materials. Here it is shown for the steels. The stress amplitude corresponding to the infinite stress cycles. The magnitude of the stress amplitude is at 10 power 6 cycles, represents the endurance limit of the uh, material. So here you can see at 10 power 6 cycles, the corresponding stress value is known as the endurance limit. That is, when the stress induced in the, or the stress to which body is exposed is equal to this endurance limit, it is found that the member is going to last for more than or equal to 10 power 6 cycles of operations. And if it is subjected to greater amount of stress values, that is above the endurance limit, the member is going to fail at a lesser value of number of rotations. So 10 power 6 or more, it is subjected to the endurance limit, and when the member is subjected to greater value of stress, and the graph is lifted to it is shifted to the left, and thereby you can see the corresponding number of cycles are less. It may be 10 power 3 or 10 power 4 or 10 power 5 like that. So this area is called finite life, and this area is called infinite life. And this SN diagram is also known as Waller's diagram, and it is plotted on log versus log graph paper. The factors to be considered while determining the endurance limit. The endurance limit of a component is different from the endurance limit of rotating beam specimen due to number of factors. The difference arises to the fact that there are standard specifications and working conditions for the test, while the actual components have different specifications and they work under different conditions.